So I have this bum in my Compass class. He's actually a new guy. I'll leave with that. So it's all quiet in Compass, and I didn't assign anyone today. I'll probably get in trouble for having 0 people in Compass. I'm supposed to have 5 a day. So oh well. So it's all quiet. Usually people are on their phones. So all of a sudden I hear a conversation. I'm like, what? I'm not too annoyed by it, but guy's on the phone. Oh yeah, I could be there at 4. Well, make it maybe 4:30. I'm like, well, hold on a second. So I go to him. I go, dude, you got to put that phone away. There's no phone calls. And this guy's kind of new to the district. I think he just moved. Completely ignores my existence. I don't even exist in the world right now. And continues for the phone call for 3 minutes, a good 3 minutes. How do you think Mr. Samuels felt about that? So I can't, these days, you can't grab the phone. You can't, so I just sit there. I'm like, really? And I just stood and stared at him face to face as he's like talking on the phone. So then it turns into, he finally gets, I go, dude, what are you doing? You can't just take a phone call in the middle of a classroom. I've never seen anything like this in my life. He mumbles something and starts walking out. I go, no, we're going to the dean's office. So he goes outside. He starts like high-kneeing it down the hallway. So what do? I high-knee it with him. Oh, I can do this too. So I high-knee. It wasn't necessarily running, but he's high-kneeing it. So, I got you. I'm right behind you. I'm like squawking or whatever. So he gets around there. He does the loop, and I catch him on the loop back there, by the, going towards the science rooms. They go, dude, what are you doing? You're making this worse. You don't think I can get your name on my list? Let's just go to the dean's office. So he starts going, and I'm looking at him and go, you're not coming, are you? He goes, dude, you do whatever you got to do. I'm like, all righty. So I went down to the dean's office. He skedaddled away, refused to come with me. And that was my day today. Oh, man. The blood's flowing right now. So just telling the story gets me all hyped up and ready to go. So anyway, tan and cotan graphs. Nice little, so literally happened today. So we got him, no. I went down to the dean's office with the write-up. Got a dean's assistant, the cover your nose guy. Cover your nose. We went up there together and got him out of the room. So made it worse than it needed to be. All right, so for tan, remember, for both of these, the period is pi, not 2 pi. So things to remember for, yes, Friday. Friday, we have a test. All right, we're going to shut it down there and then move on to chapter 5, which could be pretty rough here. But so hopefully we do well on this. What's wrong?
Instead of saying quiz, you said test.
It's a test.
It's a big
T. Big T, big test. All right. So what happens with tan is the period's cut in half. So, I put this before. This asymptote is actually at half of the period and negative half of the period. So things to remember for this. This gets really hairy, crazy, though, when we get these shifts right, left. This is going to be a pain. Tangent's the biggest pain because we have to remember that. But then when it gets shifted, oh my gosh, then, we got to remember some other things and it gets crazy. I think cotan's a little bit easier because whatever the period is, that's where the asymptote's supposed to be. And then the first one's at 0. So when that gets shifted right or left, you just go to the shift value and that's an asymptote. You get that? So if I'm shifted pi over 4 to the right for cotan, the first period or the first asymptote's pi over 4. Make sense? For tangent, we got to do a little bit more figuring, and it's more of a pain. So the only thing I really have is 3 examples of this, and we are going to break this down into what is the amplitude, what is the period, vertical shift, because the other teachers do like asking you those over and over again. But that's actually not even right. I do too. I do like questions where you don't necessarily have to graph, but you have to fill those in. And on Friday's test, that's a perfect matching opportunity. All right, maybe not so much with these crazy phase shifts because it is kind of hard to find the asymptotes when there's a crazy phase shift. But I hopefully you get what I get. And then I will tell you, I assigned out of the book. I love this book. I don't love the examples that they have in there. So I gave a similar example of what happens with this phase shift compared to the period. Some of their phase shifts are meaningless in the book. Remember what I said? If your period is pi and your phase shift is pi to the right, what actually happened? Anything at all? Anything special? 3, 2, 1, go. No, because if the period's pi and the phase shift is pi to the right, then basically a graph just gets cut and pasted right on what used to be there before. And then everything goes accordingly. So the phase shift is actually meaningless. Or the phase shift is too big and you need to reduce it because it's okay to do that. And that's what's going to happen on this one. All right. So anyway, just keep that in mind. All right, everybody. Let's do group responses. What's the amplitude? 3, 2, 1, go. There isn't one. Whoever said 3, wrong. You're gone. There is no amplitude. There is no high-low value constricting this graph to a high-low range. The range is unlimited on this, or it goes on forever. But there is an A value. So be, Mr. Samuelis. Oh, one more thing we got to do. We got to yank out that 2. So y equals 3 cotan. Pull out a 2. Oh, no. What does 5 pi over 4 become? Let's see if I've trained you. Is it 10 pi over 4 or is it 5 pi over 8? 3, 2, 1, go. It's 5 pi over 8. When you take a 2 out, you divide this by 2 to see what's, to get what's left over, not see what's left over. And then you should know that when I take 2 and multiply it back in, the 2 and the 8 cancel and I get a 4. So good FOILers, good distributors, good factors. Throw a 2 in there, 2 and 8 cancel to be a 4. I'm all good. And then the plus 1 is 1 up. Okay, this is what's stupid. The period is pi over 2, and I think I did this on purpose to match your homework. The period is pi over 2. So from 0 to pi over 2, I'll have a complete graph. And then another pi over 2, I'll have a complete graph. And then another distance of pi over 2. When we look at this phase shift of 5 pi over 8 to the right, this is what you need to understand. Your book does this numerous times on your homework. Sometimes the phase shift is pi over 2. Then guess what? Cancel it because it's useless because you're just pasting right on top of what used to be there. The problem with this phase shift is it's more than a period. Because what's 4 pi over 8, everybody? 3, 2, 1, go. So really, I'd get the same thing if I would just shift pi over 8 to the right. Whenever your phase shift is bigger than the period, then account for it is the best way I could say it. I mean, you can go 5 pi over 8 to the right, but you'd have to go way, way, way right of the y-axis to show where that actually hits. And I could actually show that. But then understand everything. This graph goes on forever. So graphs from over here go over here. That's why this is kind of useless. The cutting and pasting aspect, if we were to draw this graph infinitely, which we're not going to, the most we'll ever do is 2 periods. All right, now listen to this. Look. This is what the other group is doing. They're not doing what we're doing, taking pi over 2 and then cutting it into a fourth on the side of a sheet anymore. And I think I'm going to do what they're doing from now on. Because what ultimately I end up doing when I do that is finding the fourth of the period value. What's a fourth of pi over 2, everybody? 3, 2, 1, go. Pi over 8. So what I mean is this is the glory of this graph paper. Every mark should be pi over 8. We should be going pi over 8 every mark on our x-axis. Does that make sense? That's what I did before. I'd go like this. I go, okay, guys, let's go 4 marks out. No, we go out to here. All right, this is pi over 4. Hey, everybody, what's half of pi over 4? Tell me. Oh, I'm sorry. What's half of pi over 2? I apologize. What's half of pi over 2? Pi over 4. What's half of pi over 4? So by doing that, we got the 1/4 of the period value. And then what would we do? 1 pi over 8, 2 pi over 8, say it. Then you would do 3 pi over 8. We did the same thing that they did. The other teachers are just harping on the 1/4 of the period value so they can mark their axes better. You know what? I don't like going by 1s there because of the spacing. So I'm going to go by 2s. You don't have this graph paper, but give yourself space. I'm going to make that pi over 8. And that's where my graph is starting. Oh, by the way, there is a vertical shift of up 1. Careful on that, Mr. Sanders. All right, and then we'll do the asymptotes at the end when we find them. Actually, I already found one of my asymptotes. Because what does cotan start with? Does it start with an asymptote, or is that the zero value? That's the problem with tangent. Tangent, when I shift it, that's this value right here. What's cotan start with? 3, 2, 1, go. Asymptote. There's our first asymptote. And that's how you got to do this. You got to go pi right and then understand, how does cotan start? It starts with an asymptote. And the reason this did work out nice, it's all about this. It's all about the quarter of the period value. The period is still pi over 2, but I think we're going to do this from here on out. We're going to get a quarter of the period value and then mark from here 1, 2, 3, 4 quarters of the period is what we're going to mark. And that distance is equal to pi over 8, luckily equal to at least what I converted the phase shift to by knocking off a period's worth. Anyway, what's pi over 8 plus pi over 8? 2 pi over 8, which is what? Pi over 4? Whoa, that's my mind going off into. So 1 pi over 8, 2 pi over 8, say it. 3 pi over 8, say it. What's the next one? 4 pi over 8, and then cancel. 5 pi over 8, no canceling needed. And guess what? That's where our other asymptote is. Okay, so now we have that cotan shifted and we got our spacing very nice. So this one did work out well once we get rid of this 4 pi over 8. I will tell you, if you did 5 pi over 8, this is where your graph should have started. It should have started right here. You get it? 5 pi over 8 to the right, it would start way to the right over here. What I would hate, though, is your bad spacing. Some people put like 5 pi over 8 right here, right next to the origin. That's gone, right? I don't like that anymore, especially with these, getting into this coordinate plane thing, getting your spacing down. So that's another reason why we wanted to lop that off, because I just knew we'd get the one before this, this 5 pi over 8 shift, the one that's right before that. Anyway, we got to go up 1, and our A is 3. So instead of 3 to negative 3, I go up 1. What's my value I want to mark here? 4. And then what's the value here? Negative 2. We are going to go by ones. So 4 is what I want to mark. 1 is what I want to mark, because that's up 1. And negative 2 is what I want to mark. And then after that, it's all good. I look at the parent. The parent cotan, since it's not flipped, is decreasing. So I should be asking this of people. Pi over 4 comma then. Which one is it? 4, 1, or negative 2? 3, 2, 1, go. 4, the high point. And then 3 pi over 8 comma. 1, and then pi over 2 comma. Darn it. I always try to avoid that. Then now that you commit to these, this coordinate plane, you can go backwards. Backwards pi over 8. That counts. Backwards pi over 8 certainly counts. Backward pi over 8, that's that pi over 4, which we're getting a cut and paste scenario going on here. 1, 2, 3, you need a fourth. Negative 3 pi over 8. So yeah, that's why I gave you that coordinate plane stuff. Didn't give it to you for the notes. Do the best you can. And then same old, same old. High, middle, low. Did I do that right? I feel like I did something wrong. Yeah, shaky. Because my hand's in the way. All right, and then now we could do the asymptotes, which is x equals pi over 8's the first one, plus, how far away are these? People have a tough time with this one. And it's half the period. The period is, actually, I'm sorry. It is the period. That's my bad, dog. Pi over 2, that's what separates the period for these. Wife gave a great reference about this non-homework doing and these charlatans that don't do their homework or copy it. When you watch basketball and, that looks easy. I could throw it in. Oh yeah, I could do that. Is that how it's going to happen? Can you just walk on the court and be a professional basketball player after watching it? Yes or no? No, you got to practice. All right, you got to practice this stuff because I see a lot of people in tune and watching, but then I also know a lot of you don't do your homework, and then you complain about when you get something on the test. That's like complaining about watching basketball and then going on the court and getting your butt kicked by the other team because you don't do any practice on the court. Anyway, just thought about that reference as talked about that over the weekend. So I always see people like kind of looking, but then I'm like astounded why some people don't do as well as they should. It's not rocket science. All right, so there is no amplitude, none. We are going as I guess I like 3 as an A value today. The period is just pi. Okay, this one's gonna stink. And this is, I kept this one on purpose because the 1/4 period value is, so the period's pi. The 1/4 the period is simply that, pi over 4. But then the phase shift is left pi over 3. And what I want to try to teach you, and I'm a little nervous about it right now, is how do I mark up my x-axis appropriately to get the correct distances? By the way, who's bigger, pi over 3 or pi over 4? 3, 2, 1, go. Pi over 3 is bigger, all right? So the only way you could do this is really think about this maybe as a common denominator, I guess. I'm probably going to screw this up, but I didn't think about this ahead of time. You're definitely going up 2. So we're going to go 1, 2, 3, 4, 5. We could get that out of the way. 5 up 2. You don't really want a dotted line for the new x-axis because it's not like sine and cosine for secant and cosecant. It doesn't create any asymptotes. Just make a mark where I'm supposed to mark that, and then -1, right? 3 to -1. I'm kind of stalling because I'm trying to think. All right, so it's kind of cool this is happening because we're kind of working this out ahead of time here. So my point is, how far do I make this? Like I'm going left pi over 3, but I don't want to make that pi over 3 because pi over 3 is bigger than pi over 4, and then I'm off my marks here. I want to get a mark that these have something in common. So I think the only way I could do this is thinking about this as a common denominator, maybe times 4 and then times 3. Okay, so that's 4 pi over 12, and that's 3 pi over. Do I really want to go by 12ths? That's really going to destroy my x-axis. This one really stinks. This is a pain. So I'm probably going to go 1, 2, son of a nutcracker, 3, 4 pi over 12, and then this is pi over 3 to the left. So that's 4 pi over 12 negative. Sorry. All right? Because then after that, so I move 3 pi, and then I have to move pi over 4 for each consecutive thing here. So did I do this right? 3 pi over 12, is that pi over 4? Isn't that right? Oh, so now I'm going to have to go by ones after this. Oh, no. So that is 4 pi over 12. Let me make sure I did this right. 1, 2, 3, 4 pi over 12, 3 pi over 12. And I do have to move 3 pi over 12 after that. So actually, I am good right there. Not just one mark, 3 of these. So the quarter value is 3 pi over 12 that I'm going to move for each next one. So 1, 2, 3 notches. All right? So I'm going to move here. This is my next x value. This is what stinks. Remember I told you what's bigger, pi over 3 or pi over 4? Pi over 3 is bigger, so pi over 3, there should be another iteration of the period right here. You see how this is tough? All right? So you know what that is? What did I say this went by? Pi over what? What did I say these go by? 12. So guess what that is? That's negative pi over 12. This is how the other class is handling this. That's so you get your spacing correct, though, in relation to the origin. All right? So I get the shift, but then I put the shift in terms of the quarter period value for my markings on this. And now the shift is pi over 3, which is 4 pi over 12 negative to the left. And I still have to go 3 pi over 12 for every next important point. Stinks, doesn't it? All right, so I have to go 1, 2, 3, 1, 2, 3, 1, 2, 3. So we handled it 1, 2, 3. So really it is about common denominator. All right, so this is going to be the worst one of the day. So that's negative pi over 12. This is 2 pi over 12, which is pi over 6. 3, 4, this is 5 pi over 12, which is nice. And this is 6, 7, 8 pi over 12, which is 2 pi over 3. Whoops. I don't know what just happened there. I accidentally hit where's my mouse? You see that? Why is that question? What happened now? What's going on? I'm freaking out, man. Oh, there it is. Okay. What happened there? Is that just in the middle of the, oh, there we go. Okay. Excuse me. What is happening? Just spit on the keyboard. I hope it short circuits it. All right. 6, 7, 8 pi, 2 pi over 3. Okay. This would have happened if I did this. Remember 0 to, I'm going to do this real quick if you hate this. 0 to pi. Gosh, pen's going crazy. Half of pi. Half of pi. 1 pi over 2 pi over 4, 3 pi over 4. And then subtracting pi over 3 from everything. This would have been the same. Yeah, well, I'll tell you what's going to happen on this one. We'll get it. It's going to start at 0, 0. It's like the 0, 0 points. It's first thing. Yeah, so we're at where the y-axis is supposed to be, which is 0. Look at what 3 pi over 3 minus pi over 3. It's 2 pi over 3. So if I would have, Jacob, are you still paying attention over there? All right, good. You're not on your phone down there. You were looking down like something interesting. Are you? Okay, I thought maybe is this phone in this hand? Are you sure? All right. Told you about the phones today, didn't I? Okay, so here's the problem with tangent. This is the point that I started at. That's where we're at. We're at the y-axis and then shifted. So what I have is 0, then the next point, which is the high point, then the next point, which is the asymptote. And that's what really stinks about tangent. So I'm at 0 for this point. Wrong. Where am I actually at? 5, 2, or 1? 3, 2, 1, go. Everyone should be able to answer that. Not 0, but 2. And then the next point is 5. Okay, and then the next point represents the asymptotes. So that's how tangent starts. Tangents start at 0, 0. And then it increases. And then the next point is after the increase value at negative pi over 12 is the asymptote. Then when you go to 5 pi over 12, that's the next iteration. I did it again. Low point and then 0. Right? And then that's what you have here. So you have this, and then you have this part of the graph. That's what stinks about tangent. It's not near as nice as cotangent. But now we can finish this off by going 3 marks here. So this is 4, 5, 6, 7 pi over 12. Nope, I'm going to go above negative 7 pi over 12. Because that is the low point. That's actually a bad way of saying, whoa, I'm way off. The lower of the 3 values. And then the next one is our next asymptote. I guess I'm going green. 1, 2, 3. So now that I hit green. Now that I got these spacings out, I can actually do the math a little bit easier. So 3 pi over 12. Did I go too far? 3 pi over 12. 1, 2, 3. So this is 4, 5, 6, 7 pi over 12, 8, 9, 10 pi over 12. 10 pi over 12 is negative 5 pi over 6. And then that ends up being this. So I would have got those same initial values if I would have done our math off to the side work. All right, 3 pi over 4 minus pi over 3 is probably that 5 pi over 12. Yes, you get this to be 9 pi over 12. And this is 4 pi over 12. There you go. So it does work out. All right, and then I can continue that and actually see the graph. All right, I only got one more, and it's not going to be that bad. This one's awful. All right, 2 pi over 3, which is back to 5, 6, 7, 8, 9, 10, 11 pi over 12. 9, 10, 11 pi over 12. 12, 13, 12, 13, 14 pi over 12. 7 pi over 6. Is anyone listening at this point? You are now, Jacob, after I yelled?
Yeah.
Thanks. Phone call right in the middle of class.
What if it was important?
What if it's a drug deal? All right. We're playing what ifs. I mean, what if it was? I mean, so I'll meet you at 4 o'clock was part of the. I don't know. You never know. Actually, I had a story about that. I had to teach, the first time I had to teach math 2 regular, which was 2015, I believe. Oh my gosh. One kid actually ended up getting arrested after he left school for stealing packages off of Amazon packages off of, I remember who he is, remember his name. And then another kid was a son of a bunch of drug dealers. And I found out by the time some of the girls that were in that class were seniors, they said they were really good students. They said, yeah, every time you walked away, he would talk about drugs. And like, I'm like, oh my gosh. I knew it. I knew it. I knew he was a hooligan. I knew it. I'm just telling you the truth. This is the truth. This is what happens. That's all I'm saying. Hey, what happens when I pull out a half? What does pi over 6 become? Is it 3 pi over 6 or is it pi over 12? I'm sorry. Is it 2 pi over 6? Correct. I'm sorry. That's why you had the face. Is it 2 pi over 6, which of course reduces, or is it pi over 12? It's one or the other. You either put the 2 on the top or the bottom. Which one is it? Top. It's 2 pi over 6, which is what? Pi over 3. Okay, I hope this may stink. I don't know. And then minus 2. Sorry, I'm in the way here. Okay, so there is no amplitude, but A is 2. We'll stop tricking you on that. The period is pi over 1/2, which is what, everybody? Oh, this is going to be another one that stinks. You're going to hate this. But you know what? Cotangent's easier. We'll just do 1 period. So 1/4 of a period, 1/4 of a period equals pi over 1/4, 2. Yeah, sorry, I'm struggling. And the phase shift is, it stinks. Thanks, Santino. You're making me feel better. It's okay, Mr. Sanders. We're pi over 3 to the left again. And now we're down to. This is the kind of question in the matching where it will be, Carly, what are you doing? All right. This is the kind of question which would be in the multiple choice, matching section. You wouldn't necessarily have to graph this. Hold on. Is that a picture of me? What is this over here? What is that? What is that? That looks. Where's the eraser? That looks nefarious and something wrong with that. You people and your markers. What is this? What is that?
Look at the heart in the back.
Yeah. Kids, it's just unbelievable, man. Just unbelievable. Just unbelievable. What? Is there more? Was it you? Becky, was that you that did that? Oh. Is there something else back there? Hold on. This is teaching in the United States. Give me that one, Risa. What's going on back here? Raise that bill. That probably has some sort of meeting too. Oh, no, nobody loves me. Come on. Oh, all right. Here, put that back. Thanks. Okay. There's something else there. Okay. So cotan's a little bit easier. Down to, so we're going to mark this. I don't even listen anymore. So we had 2 to negative 2. You go down to 0. And then 2 to, thanks, computer. So we got 0, 2 to negative 2, 2, and then negative 2. These are, or negative 4. -2 and -4 are the values I gotta really be aware of here. Okay, and I think we have the same thing. So we're going pi over 3 to the left. Okay, no, this is good though. The fourth of the period is pi over 2, so we're going to go by pi over 6. The common denominator is 6 on this. Times 2 times 2. Okay, so we have to go 2 pi over 4 every move after this. So we want to go, I'm sorry, 2 pi, that was terrible. This is supposed to be over 3. 3 pi over 6. We got to move 3 pi over 6. We got to move 3 notches. So 2 pi over 6. So this is one where this is bigger, right? So that's why we're going to go 2 pi over 6. So every move is going to be pi over 6. We got it, all right? That's what, when we get our common denominator, we'll move by pi over 6. That's how we kind of do this. So we have to move 3 pi over 6. We have to move 3 notches for every next thing. So I moved 2 pi over 6, which is 2 notches, which is pi over 3 to the left, negative. And then 1, 2, 3 notches is a period move. So it's 1 notch past the origin, not 2 notches. I got that 0 in the way. I'm going to erase that. I know that's 0 there. There we go. So my first notch is pi over 3 to the left. And then I move 3 notches because every notch represents pi over 6. 1 pi over 6, 2 pi over 6, 3 pi over 6. That's a fourth of the period. This is what the other class is doing, and I like it. 1, 2, 3, another 3 pi over 6, another 3 pi over 6, and another 3 pi over 6. 1, 2, 3, and I got it. So this is pi over 6 because it's just 1 notch right of the origin after you move 3 notches from negative pi over 3. And then 1 pi over 6, 2, 3, 4 pi over 6, 4 pi over 6. 5, 6, 7 pi over 6. Now it's working. 8, 9, 10 pi over 6. The pen is really being a jerk right now. And then here's what this graph is. It's a cotan. So cotan, the beginning of the graph at negative pi over 3, is an asymptote. So that's why I like cotan a lot better. Tan's a little bit more of a pain. And then cotan, there is no flip upside down. Cotan decreases. So at pi over 6, that's 0. At 2 pi over 3, that's -2, the middle point. At 7 pi over 6, that's that point. And then at 4 pi over 3, you have your next asymptote. So you would have got the same thing if you would have 7 pi, 8, 9, 10 pi over 6. You're right. 5 pi over 3. Thanks, Santino. You are paying attention, and I'm done. No, it's good. I don't have any more. Those are 2 awful ones. I really don't think it's going to be that bad on the test Friday. You literally ran into the most ugliest shifted questions you could run into. In the homework, I swear to dog, your first one, I think the period's pi over 2, and the shift is pi over 2 to the right. Does that have any meaning whatsoever, yes or no? 3, 2, 1, go. No, you could ignore the phase shift and just graph the graph, as it is. So I really want you to know on that. Oh, boy, what an emotional day.